Hello, my name is George, and today I'm gonna show you how I implemented a state pattern using Unity. So before I had three scripts, character jump, character movement, and character controller. Let's be honest, most of the functionality was in the character input controller script, so as you can see there was a lot of code, so it was responsible for a lot of things. And I was using a lot of nested if statements, and if I wanted to continue on this project, I would definitely add more and more if statements nested to each other, and it would start to be pretty messy. So I decided that I want to make my own state pattern or my own state machine. And as an example, if I press play, if you watch closely the console, you can see when I'm moving, I'm in walk state. When I'm in idle state. If I jump, I'm in jump state. And if I'm falling, I'm in fall state, and etc. etc. So basically, I'm changing the states, and each state has its own functionality, and it's much more cleaner code. And if a new person understands properly the state pattern, it's really easy to read, and I would say much easier to increment new functionality to the scripts. So let's get to a drawing board. So state machine or state pattern is a design of code where you alternate through individual states, as you could see before, and each state is a class with its own functionality, and each state can change the state to another state. So I can have, let's say, three states. State 1, state 2, and state 3. And each of the states can have some lines of code that it does some functionality. And if the condition is met, the state can change to another. And the other state can have its own functionality. Let's say it has more lines of code. And if another condition is met, it can change to another state. And maybe the other state doesn't have as much conditions, so it might have only 2 lines of code. And it might change the state to a first state. And we can have a lot of states like that. I show example with 3 states. We can have much more. My script, my state machine has around, 8 or 9 states, and I can be adding more and more. But the complexity would grow pretty fast. So that was a basic explanation of how state pattern or state machine works. And let's look at how the ideal implementation might look like. Disclaimer, I'm not saying that this is the 100% correct way how to implement the state pattern, but it's just my understanding of the topic and how I implemented it for my needs. So if you have some insight on how to make it better, or you think that I did it completely wrong, you can let me know in the comments down below, and I'm gladly gonna learn from your experience. So in my case, in my implementation, my super state is called base state, and it's an abstract class, which means it can have some implementation. It's a little bit different than interface, but basically abstract class means that we can have some implementation and we don't have to have an implementation. And our base state, our class base state, has a constructor that expects 2 values. The first value is context. In our scenario, the context is gonna be class player, but I'm gonna explain it later. And the second parameter that the constructor expects is a state machine. The state machine is responsible for changing the state. And also, our base state abstract class has 5 primary methods. The first method is enter, which is gonna be executed once when we change to the state. It's gonna have handle input and logical input. They are pretty much the same because they are both executed each frame. We're gonna have physics update method, which is gonna be executed in each fixed update, and the exit method, which is gonna be executed at the end of our state when we are changing to another state. So the visual representation of our abstract base state is gonna look like this. We have an abstract class. We have a constructor that takes our context and state machine. And we have 5 methods of total, which are the main methods. And they are all virtual. And virtual method means that it can be overridden in any child that the class have. So if our base state class has a child, the child can override any of the 5 mentioned methods. Let's look at that. So I have my base state, and let's say I have a virtual method exit, and if I click into my idle state, as you can see, it's called idle state, and it's a child of a base state. So it's inheriting from our base state. And in the idle state, if I scroll a little bit down, I have overridden my exit method, and I'm calling the base.exit. That means that if I had any functionality in my based state, let's say I had something like a debug log hello world, and if I changed to an idle state and then changed to another state, that means that when we are leaving our idle state, it would still print the hello world because we are calling the base state. That means we are calling the exit method of a base state. So this code would be executed. And similarly, it works for the other states as well. So for example, I have a jump state, which also derives from base state, and we override all the 5 main method. It's same for the walk state, same for every other state. We can override all the methods if we want. I'm gonna show you just in the walk state. We have our walk state, which derives from base state. And as you can see, we are overriding enter, we are overriding handle input, overriding logic update, physics update, and exit. So we are overriding all the main methods. And next in the line is our state machine, which is responsible for changing from one state to another. State machine is pretty short script. We have only 3 things really. It derives from mono behavior, so nothing special. It has one property called current state, which we can get from anywhere if we have instance of state machine. And we have a private set, which means that we can set a state in the state machine itself. We have method called initialize, which is nothing more than just setting our current state to a state that we assign it. So if I want to start with, let's say, idle state or walk state, I can call this method and it's gonna initialize to the current state, the state that we give it to the method. And the most important thing in the state machine is gonna be change state. It's a method change state, which accepts one base state or one value. Sorry about that, I had to turn off my light because it was making a weird noise. So it accepts a value that is type of base state, which is our super state. And on our current state, it calls an exit method. So when we are changing the state, we are calling our exit code on the current state. After we call the current state exit, we set to our current state the new state that we passed to our change state method. And at the end, we are calling on the new state that we just passed, we are calling the enter method. So if I am in the idle state, and let's say I'm changing the state to move or to walk state, the exit on idle state is gonna be called, the current state is gonna be changed to a walk state, and we are gonna call the enter method on our walk state. So that's all from our state machine. And the final piece is gonna be our context. Our context, in my case, is called player because I am using the state pattern for our player. It also derives from mono behavior, so nothing special. What is important here, we are creating all the states here. So I have the idle, walk, jump, fall, run, dash, wall grab, wall slide state, all the states I have here. In my awake method, I am initializing all the states. That means that I'm making new instance for each of the states. Since our constructor in the state takes two parameters, the first parameter is accepting the context. And since we are in the context, we are passing this script to each state. And the second parameter in our constructor wants a state machine. So we are passing state machine that we cached in our awake method. We need to cache it before we initialize the states because the state machine would be null. And the state machine is simply just a value that is type of state machine. I'm gonna go back to the constructor so you can see this. If I go to base constructor, we want our player that is type of player and the state machine. So that's exactly what we are passing here. So we created instance of each of the state. Then in our awake method, we are calling on the state machine. We are calling the initialize, which is the first state. So we are setting the first state that we are gonna start with. In this case, we are starting with idle state. And the last important thing is that on the current state, we are calling handle input and logical update in our update loop. So every update, we are gonna be calling logic update method on each state. So if let's say I am in false state and I go to a logic update, this piece of code is gonna be executed every frame because logical update is overridden from our base state, which is here, logical update. And logical update is called every update in our update loop in player. And in the same manner, we are calling current state.physics update in our fixed update loop. So this is for physics. So in my jump state, I'm overriding the physics update and I'm calling this piece of code, which adds velocity to my character. So I'm setting it up to be jumping. And same as before, it's a physics update method. And physics update method, if we are in a jump state, our player script is gonna be called every fixed update. We are calling the physics update. And the two remaining methods I already said before, the exit and enter method is called in our state machine when we are changing state. When we are changing from one state to another, we are calling exit on the state that we are changing from, and we are calling enter on the state that we are changing to. Okay, so let's recap. We have our state machine, which has a value current state, or property, should I say. It has initialize and it has a change state method. And it is in our player script, which has all the states here. And since our every state has a constructor that takes a context and a state machine, so we are passing to each of our state, we are passing the player script, because player script is our context, and we are passing this state machine. This state machine is this state machine here. We are passing that to each of the state, and since each of the state has it, we can access state machine from each of our states. Also, in our player script, in update loop, we are asking, okay, what's the current state? And the current state from our state machine is gonna tell us, okay, let's say it's idle. So it's gonna tell us, okay, we are in idle state. And in our update loop, we are calling the logic update in the current state. And since the current state is idle state, so we are gonna be executing a logical update in our idle state. We are gonna be executing this every frame. And if in this method is some code, it's gonna be executed every frame. There also could be condition. If something happens, let's say if I press to the left or to the right, there could be a code that is gonna call our state machine, and it's gonna call change state, for example, to a walk state. So if I am in idle state and every frame this piece of code is executed, and there is a condition that is asking if you're pressing to the right or to the left, change the state, and if I press to the left or right, this piece of code is gonna be called, and I'm gonna pass in the state that I want to change to. Since I want to change to a state that is moving, I'm gonna pass a walk state, which is this state. So our state machine is gonna change the current state, which is currently idle state, and it's gonna change to a walk state. But before it do that, it's gonna call exit on our current state, which is still idle. After that, it's gonna change it to the walk state, and it's gonna call enter method on the new state, which is the walk state. So it's gonna execute this piece of code. And in our walk state, we can also be asking something in our logical update. Since our player has an update loop which is executing every frame, and we are asking, what is the current state? The current state is our walk state, and we are executing logic update every frame. So we are executing logic update of the current state, which is now the walk state. And there could be another piece of code that is gonna be calling another state. That could be, I don't know, dash or jump or anything else. And it's basically cycling through over and over, and it's calling another state. Okay, now let's call this state. It works, but there is a lot of duplicate code. And since I had some piece of code that I wanted to be executed from a lot of states, I put some of my code into the base state, which is probably not the best option. So I don't recommend you to do this. I'm just gonna show you how I implemented it. So you might have seen that I don't only have the 5 basic methods in my base state, but I also have some other methods like flip, idle, jump, fall, because I can jump pretty much from anywhere. And I don't want to write in each of the state that I can jump if I press the space button. I can write the code here, which is gonna be this, and call the jump each logical update. And since all of our other state is overriding the base logical update, and in every state I can call the base logical update, it's gonna always execute the jump if I want to. And if I don't want to execute the jump, I can override the jump method and put nothing in it. For example, I have my move input which is always horizontal input. But if I am touching a wall, I don't want the player to be adding the force to the wall because I would get stuck slightly. So the move input in the base state is executed in every handle input, which is theoretically every logical update. And when I go to my wall grab state, I am overriding the move input. So we get the horizontal input only when we are not pressing the key to the side of the wall. So in this case, the base method is not gonna be called because I don't have the base.move input, but instead I'm overriding the move input, and only this piece of code is gonna be executed. And if I go back to the jump example, let's say I don't want to be able to jump from idle state. And since we have this jump method, which is executed every virtual logical update, I can override the jump in the idle state. So I simply go to the idle state and I would write override, and I'm gonna choose jump. And this would still execute the base code, but if I comment it, or if I delete it, it doesn't matter. Now we are not gonna be able to jump from the ground. Now if I try to press space, I'm not jumping, but I still am able to jump from a wall because in my wall grab state, I'm overriding the jump, so I can only jump when I press the key. Because originally I had if I'm grounded and I am holding the key, and I did not want to player be able to automatically jump when it lands back on the wall. So I override it in my wall grab state. So I will be still able to jump when I get back to the wall. I just need to move the camera a little bit. And I press space and I'm still able to jump. But when I'm grounded, I'm not able to jump. Because I have overridden in my idle state the jump method. If I put base.jump back, I will be able to jump. As you can see, I'm pressing space and I can jump from the ground. Okay, so once more, the final recap. We have an abstract base state, which has enter, handle input, logic update, physics update, and exit methods. They are virtual, so every child can override them. And we have all the other states, like idle state, jump state, dash state, and they all have the 5 main methods, and they override them. So each state is a child of a state, of a base state, and they override enter method, they override exit method, they override all the main methods, and they can add their own functionality to those methods. In our player script, which is the base script of our character, we are creating all the states, we are initializing them with our player script, which is this word, and we are initializing them with a state machine. State machine is a script that is responsible for changing the states, and the change state looks like this. So we are calling on the current state the exit method. We are changing the current state to the new state that we passed into the change state method. And we are calling the enter method on the new state. And the change state can be called from each of the states because we are passing that in the constructor. And in our player, we have our fixed update and update. And in each of those, we are asking what's the current state. And on that state, we are calling the logical update and physics update. Okay, my voice is kinda starting to collapse, so I'm gonna end the video here. I hope it made some sense to some of you. If it did or didn't, you can let me know down in the comments. Also, I would be super glad if you could press the like or dislike button to let me know if the video was good for you or wasn't. And if you want to see more videos from me in the future, you can press the subscribe/bell button. That's gonna be all from me, and I'm gonna see you next time. Bye!